Hello students. So this is our new video where we are going to learn about the next model of atom which was proposed at that time to eradicate or to remove all the drawbacks of Bohr's model. Okay. So according to the name of the scientist, the name of the model is Sommerfeld's model. So today we are going to learn about Sommerfeld's model. So in Bohr's model, we have learned that Bohr's model was failed to explain the fine splitting or the fine nature of the spectral lines that we observed in hydrogen spectra. Okay, so to give a satisfactory explanation of the fine splitting or of the fine structure of the spectral lines, Sommerfeld has given few proposals, or he has added few proposals to the model of Bohr, okay. So what are the few points that he has added to Bohr's model? So the first point is that point number one is that all the orbits, okay, the orbits in which the electrons are rotating around the positively charged nucleus, those orbits are not only circular but they can also have an elliptical structure. The orbits can have an elliptical structure in addition to the circular shape. Okay, so this is the first point. Second point is that the nucleus is present at one of the foci. As we know that an ellipse, it has two foci or focus. Okay, so in any of its focus or in any of its foci, the nucleus is present. This was the second point. Now the third point is that when the electrons are rotating around the nucleus in an orbit, so only in those orbits the electron can rotate where the angular momentum is an integer multiple of h by 2 pi. That means just like the Bohr's theory, there we have seen that angular momentum, it is angular momentum for an electron, it is also an integer, multiple integer of h by 2 pi. Here also we could say the same thing, that angular momentum, that is mvr, it is an integer multiple of h by 2 pi. So here k is the integer. Okay, k is the integer, that means it is having a value which is integer, and k is known as another quantum number. So Sommerfeld also described the angular momentum in the quantized form, okay, because k is also a quantum number here. So k is actually the quantum number known as azimuthal quantum number. So Sommerfeld has given it the name, that is azimuthal quantum number. So the concept of principal quantum number was given by scientist Niels Bohr in Bohr's atomic model, and the concept of azimuthal quantum number was given by Sommerfeld in his atomic model. Okay, so it is denoted by k. So next thing is that here when the electron is rotating, here there is the nucleus and the electron is rotating in the elliptical orbit. Okay, so in this ellipse we can get two types of axis we can see here. One is this axis, that is horizontal, it is major axis, okay, and this axis which is vertical, this is the minor axis, okay, this is the minor axis, and here there is the nucleus. At any foci there is the nucleus. So now in this case, in the elliptical orbit, we could see the change, we could see the change in the angle of revolution. So this is the angle of revolution that has made between this major axis and the radial distance, the distance of the electron. Suppose here there is the electron, so the distance of the electron from the nucleus, it is called the radial distance in the circular orbit, which we know as radius, because in case of a circle the radius is same everywhere, okay, but in case of a elliptical orbit, the radius or the radial distance, that is denoted by r, that is not same everywhere. So here radial distance as well as the angle of revolution both changes with the revolution of the electron, okay. In case of a circular orbit, only the angle of revolution changes, only the value of theta changes, okay, as well as the electron is rotating, the value of theta is changing. So here the value of theta is also changing, as well as the radial distance, it is also changing, okay, in case of an elliptical orbit. So next is that, so here n is the principal quantum number that we could see in Bohr's model, and k is the azimuthal quantum number that we could see in Sommerfield's model. So there is a relation between n and k. So what is the relation? The relation is n by k is equals to length of major axis, that we could write as a, divided by k means length of minor axis, that we could express as b, okay. So n by k is equals to a by b, n by k is equals to a by b. So here, so that means whenever the length of both, that is the major axis and the minor axis, the length of them become equal, okay, whenever a is equals to b, that means whenever the length of the major axis and the length of the minor axis become equal, that means it will become a circle, or the path will become a circular orbit, because then as the distance is same everywhere, that means it will act as the diameter, okay. In case of a circle, we could see that the diameter is equal in every place or everywhere. So whenever a is equals to b, then n is equals to k also, okay. Then these two quantum numbers are equal also. So then at that time the ellipse will become a circle. The ellipse will become a circle. So that is the special case when the ellipse, it can act as a circular orbit, or it can look like it can be changed into a elliptical orbit, okay. So here the next relation, the next point, the next point is that for nth orbit, okay, for nth orbit we are getting n number of azimuthal quantum number which represent its subshells. So what does it mean? It means that if n is the number of shell, okay, if n is the number of shell, then it will contain different subshells in it. Okay, nth orbit, it will contain different subshells in it, which are represented by the azimuthal quantum number. So how many azimuthal quantum numbers are there, or how many shells will be present in nth orbit? So the number of subshells present will be n. For example, if the number of orbit is 4, okay, if the number of shell or if the number of orbit is 4, so then we will be getting 4 values of k. So here we are getting 4 values of k, okay, because here we have learned so that n number of azimuthal quantum number we will get here. So that's why when we are getting the value of n as 4, then there will be 4 values of k. So what are the values of k? So the values of k will be 1, 2, 3, 4. Okay, the values of k will be 1, 2, 3 and 4. That means we are getting here 4 sets. We are getting here 4 sets which are representing their subshells. So what are the 4 sets which represent the subshells? So the first set is n is equals to 4, k is equals to 1. Second one, n is equals to 4, k is equals to 2. Third one, n is equals to 4, k is equals to 3. And the fourth one, n is equals to 4, k is equals to 4. Okay. So that means here we are getting 4 sets. Here we are getting 4 subshells. 4 subshells we are getting, and each subshell is having their unique value of n and k. Okay, each subshell is having the unique value of n and k. So for the 4 subshells we are getting different values of n and k. Now here the last one here you can see that here the value of n and k are equal. Okay, both of them are 4. So that means here it is a circular orbit. It is a circular orbit, but the other 3 are elliptical orbit. So how many elliptical are there? 3 elliptical orbits. And how many circular orbit is there? 1 circular orbit. Okay, so that means for the 4th orbit we are getting 4 subshells, of which 3 are elliptical and 1 is circular. Okay, so the diagram will look like this. The diagram will look like this. Just like here, if this is the nucleus, then so this one that is looking as a circle, for this the value of n and k is same, that is n is equals to 4, k is equals to 4. Okay, the second one which is close to a circle, the second orbital, the second subshell which is very close to a, which is having a shape that is very close to a circle, that is having the value n is equals to 4, k is equals to 3. Okay, that means the more it is close to the nucleus, it is getting a circular shape. So for this n is equals to 4, k is equals to 3. The next one, this one, it is having n is equals to 4, k is equals to 2. And the last one, n is equals to 4, k is equals to 1. That means the more the value of k is going close towards n, the more the value of k is becoming close to 4 or is becoming close to n, the more its shape will become circle or it will go close towards a circular shape. Okay, so this is the structure. These are the circular or these are the shape of the orbits that are proposed by Sommerfeld. Clear? Okay, so next one. So now there are different demerits of Sommerfeld's theory. What are they? Just like Bohr's theory, Sommerfeld also could not give any electronic model which is three-dimensional. Here the model we have seen that is also two-dimensional. Okay, so three-dimensional electronic model could not be given by Sommerfeld also. Next is that Sommerfeld, the atomic model of Sommerfeld, it contradicts the principle that is given by Heisenberg, and it is known as Heisenberg's uncertainty principle, that tells us that at the same time we cannot calculate both the position of the electron as well as the momentum of the electron. Okay, but this theory, Sommerfeld's theory, it contradicts the principle of Heisenberg. Okay, so these are all the demerits of Sommerfeld's theory. So next model is that wave mechanical model. Wave mechanical model that is given by, that could be explained by two theories. One is de Broglie's theory, another one is Heisenberg's uncertainty principle. So first we will learn here. Okay, so next is wave mechanical model of atom. So in wave mechanical model we can see two concepts or two theories between. The first one is de Broglie's equation and the second one will be Heisenberg's uncertainty principle. Okay, so first we will discuss about de Broglie's equation. So scientist de Broglie, he mainly focused on the wave nature of the electron. Okay, that means when the electrons are rotating in the circular orbits or in the elliptical orbits around the nucleus, at that time they are having the wave nature. So as they are having the wave nature, so they should have wavelength. Electrons should have wavelength. So a relation that de Broglie derived, okay, that is wavelength lambda is equals to Planck's constant h divided by momentum. Momentum means what? Mass into velocity. Mass what? Mass of what? Mass of the photon. Okay, mass of the energy particle, that is photon, and v is its velocity. So here we could write lambda is equals to h by m into v. Okay, or lambda is equals to h by p. P is the symbol that we could use in place of momentum. So lambda is equals to h by p. So as h is a constant here, h is constant, so we could write here that, we could conclude here that lambda is inversely proportional to momentum, that is p. Lambda is inversely proportional to momentum. So next we will derive the same equation. Okay, derivation of de Broglie's equation by using Einstein's theory of mass and energy conservation and the theory of Planck's. So first theory, Planck's quantum theory. Okay, so Planck's quantum theory, according to this theory, if E is the energy of a particle, okay, energy of photon, then E has the value h into nu, where nu is the frequency, h is the Planck's constant, E is the energy of the photon. Or also we can write it as h into c by lambda, where c is the velocity of the photon and lambda is the wavelength of the photon. Okay, now number 2, according to Einstein's theory of mass and energy conservation, E is equals to m into c square. Okay, so now if we compare these two equations 1 and 2, so then we could write it that E is equals to h into c by lambda. Again E is equals to mc square. That means h into c by lambda is equals to mc square. So h into c by lambda is equals to mc square. Now cancelling c from both sides, we could get it as h by lambda is equals to m into c, or we want to calculate the value of lambda from here. So lambda is equals to h by m into c or m into v. That means this is actually the momentum. So h by p. So that is the de Broglie's equation which we have derived here from Planck's quantum theory and from Einstein's theory. Okay. Next is that quantization. So now by using the de Broglie's theory, we could get the quantum theory of Bohr's model. Okay, we could get the quantum theory of Bohr's model. That means this equation we could derive. M here is equals to nh by 2 pi by using de Broglie's equation. Now the question is how we could derive it. So for this purpose, suppose this is the nucleus and this is the circular orbit around the nucleus where the electron is rotating or the electron is circulating here. So here the radius is small r, right? The radius is small r, and as the electron can show its wave nature, so that means if we can draw the wave nature of the electron, so we are getting this type of model. Okay, this type of model here we are getting. So if there are two electrons and both of them are moving in the same phase, okay, so then there will be a combination of these two phases, or there will be the combination of the two ends for the two waves. Otherwise their ends will not meet here. So here we are taking this example which is in phase, which is the in phase model. Okay, because here the ends of the waves are meeting with each other. Okay, at this point the end of the two waves are meeting with each other. So next here, suppose the radius of the circle is r. So according to mathematics, we know that the circumference could be calculated by this formula, that is 2 pi r. This is the formula of circumference. Okay, 2 pi r. Now 2 pi r is equals to, so what we could write here, suppose for a single wave, the wavelength is lambda. For a single wave, the wavelength is lambda, and suppose there are n number of waves. Okay, suppose there are n number of waves. So for one wave, the length is lambda. So for n number of waves, what will be the total length? That will be n into lambda. Okay, for total n number of waves, the total distance covered by the wave is n into lambda. So from here we could calculate the value of lambda as 2 pi r by n. Okay, 2 pi r by n. Now the same thing from de Broglie's equation we could see lambda is equals to h by m into v. Lambda is equals to h by m into v, that we have got from de Broglie's equation, and that part we have got from this figure. So now comparing these two, we could write here 2 pi r by n is equals to h by m into v. Okay, h by m into v. Now we want to bring mvr part in this side. So just this part, that is 2 pi by r, that you have to take in this part, and mv you have to bring in this position. So here there will be mvr, and cross multiply, n will go upwards, n will go here, nh, and 2 pi will come downwards by 2 pi. So this is the quantized form. This is the quantized equation of Bohr's theory that we can get by using the de Broglie's equation. Okay, so this is the part So in our next class, we will see different examples that are related with the de Broglie's equation. Okay, so our class is over for today. We will meet again in our next class. Thank you.